Hey, welcome back. This is Mr. Kelly, and as most of you know, I'm a huge Buffalo Bills fan, and I think that football relates to a lot of us in real life. We see the emotions and the hard work, and it's just very relatable. And as I was watching the game this weekend, I thought of all of you Algebra 2 students out there because there was a moment where the Bills had finally won, and there was some relief. And for some reason, and I couldn't really quite put my finger on it, but for some reason I knew that you could all relate to that situation when you finally finished topic 1. So now we are in topic 2. Hey, how about that? This is on page 333. What I want you to do is numbers, what do we got down here? 2 and 3. Complete those like a warm-up. So pause the video right now. You have to pause the video. Hit the pause button. Do those 2, and then come back and unpause it, and we'll see how you did. All right, so hopefully you were able to work through both of those, or both review. Look at number 2. That is a difference of perfect squares. This is a perfect square. A squared is a perfect square. And so hopefully by now you recognize that. What multiplies to a squared? A and a. What multiplies to 25? 5 and 5. And that is called factoring. All right, we're all done there. It said expander factor. So that one's factoring. But this one, it is kind of factored. It's in factored form, so we need to expand it. Okay, what does that mean? Multiply it all out. And so hopefully you double distributed and you got yourself a squared. We get a minus 8a and a minus 8a on the inside, and a plus 64. Final answer is a squared minus 16a plus 64. So these are review. If you have any trouble with those, please ask your teacher. We're going to move on now to page 335. We're calculating with polynomial identities. Now, I'm going to take one of these, and I'm going to work it out to show you that it works. So let's take this first one here, a plus b squared. I'm going to do that off to the side. Let's do it over here. We all know that a plus b, quantity squared, that's how we say that. The quantity a plus b squared is really equal to a plus b times a plus b, because that's what squared means. And if we want to calculate, or we want to expand that, we would say, and see what that is equal to, then we need to do what we call double distribute. So we need to multiply a times a, then a times b. So a times a is a squared, a times b. I'm just going to write that as ab. Normally I go alphabetical on these. On the inside we get ba, but as I said, I normally go alphabetical. So I'm just going to call that ab again, because it's a times b. And then lastly I get b times b, which I'm going to write as b squared. So you notice that a plus b, quantity squared, actually equals, when I work it all out, a squared plus we have an ab and an ab, that's 2 ab's, and then a b squared. So we could say that a plus b, quantity squared, is equal to a squared plus 2ab plus b squared. Okay, well that's called an identity. Like, this is always true for every single number, every integer of a and b, every decimal, every fraction. A plus b, quantity squared, is always going to be equal to a squared plus b squared plus this middle part, 2ab, which a lot of people forget that. And if you notice, that's what's written right here as an identity. Okay, a plus b, quantity squared, equals a squared plus 2ab plus b squared. Well, in fact, I'm not going to go through all of these because that would be a huge waste of time. And we don't have time for that. But if we have a plus b quantity squared, we can do a minus b. You would get the same thing, except these would be negative. So the middle two parts would be negative, still be positive on the outside. It would just work to a squared minus 2ab plus b squared. And you could go through all of these. We could verify all of these. In fact, that's going to be part of the lesson. But each part on the left is equal to the part on the right. So we're going to use that. Okay, we're going to use that with some numbers to see how the numbers operate and to more or less validate these theorems so that we know that they work, so that we know that they are an identity. An identity in math is something that is always true. Okay, the part on the left side of the equal sign is always going to be equal to the part on the right side of the equal sign. So the first worked example, you can see it says use the polynomial identity that a plus b quantity squared equals a squared plus, this is the one we just worked out, plus 2ab plus b squared. We're going to calculate 46 squared. Well, how would we do that? Well, what you need to do is you just need to pick two numbers that when you add them together will give you that 46. So that when we square the quantity, we're going to get this expression right here that we will work out. In the worked example, they said, well, 46 is equal to 40 plus 6, right? I mean, that's 46. That's the easiest way to look at it. And so using the formula, if that would mean that a is 40 and b is 6, so that would equal 40 squared. And you can see their work right here, 40 squared plus 2 times 40 plus 6, and then plus 6 squared. And if Notice how they show each line of this, and then they work this out, and then they square the 40, and then they multiply all this out, and then they square the 6, and then you get 2,116, and that's what the value of 46 squared is. Okay, so now we are going to do 46 squared a different way. Instead of using the identity for squaring a sum, we're going to square a difference. Okay, we're just going to use this one. So I need two numbers that subtract that'll give me 46. So let me write down what that identity is. And if you notice that that is just copied from up here, right? That's just this line right here. And I'm going to use, let's see, I got to find a different way to make 46. So I'm going to use A equal 50 and B equal to 4. Because I know that 50 minus 4 is 46, right? 50 minus 4, that'll be 46, and I want to square it. So if A equals 50 and B equals 4, I'm just going to plug that into this formula. And notice that wherever I had an A, it just gets replaced with a 50. Wherever I have a B, it gets replaced with 4. Because again, we're calculating 46, and 50 minus 4 is 46. All right, so now it's just a matter of working stuff out. So 50 squared, I think, is 2,500. And then I'm going to multiply 2 times 50 times 4. That gives me 400. Am I right? And then 4 squared is 16. And so now we have 2,500 minus 400 plus 16. That all equals 2,116. That is exactly what we got when we did it using the other identity. Okay, that's not so hard. Now I'm going to do a little more complicated one. This problem is on page 336, and it's part C. I'm going to do the hardest one that they give us right here. It's 55 cubed. So I look at that. I could do it two ways. I could see that as either 50 plus 5 or 60 minus 5. I'm going to go with 50 plus 5 to keep everything positive. So then I would use my identity from the page before for cubing a number. And here is what that identity looks like. It's A plus B cubed, quantity cubed equals this whole mess. And remember, that happens because we have to do all that distributing. If we had to write this 3 times, A plus B, and we'd have to distribute the first thing, we get this huge trinomial, and then have to multiply that again. This is what you end up with. A plus B times A squared plus 2AB plus B squared. That's the identity, and we are going to know that 55 equals 50 plus 5. So in this case, we're going to use A is equal to 50, and then B is equal to 5. All right, we're going to cube that. So what we need to do is we're showing here. A lot of it isn't about getting the final answer, and that's all we care about. It's about the process of getting the right answer. And you have to convince somebody that this is actually what it is. So we're going to write the identity down or copy paste, but you're going to have to write it down. And then we're just going to substitute. Everything that's an A, we're going to put a 50 in because that's what A is equal to. So we can put a 50 there. And then everything that's a B, we're going to put a 5 in. So this is going to be 50 squared plus 2 times 50. I'm going to write with my parentheses. We've taught you how to do that. And then plus B squared. So that's going to be plus 5 squared. Now it's a matter of figuring this all out one step at a time. We get 55. Yes, I know you can plug all of this into your calculator, but again, it's about the process of showing that these two things are equivalent. So we get 500 from the middle piece and then 25. This looks like it's going to all equal, what do we get? 55 times, that's 3,025. So I need my old calculator for that. After I plug it in the old calculator, I get 166,000. My apologies, 375. And so that is what 55 cubed will equal. And that is me using the identity to show exactly what it is. Now, at the beginning, could you just cube this in the calculator? Yes, but that's not what the lesson is about, showing step by step how this goes through the process. Because there's going to be more complicated expressions that we're going to do with this. So we're starting with numbers. That's really why we're doing this. And in fact, now it's your turn. So I want you to do part A and part B on the same page. We're going to do that on your own and then come back. So pause the video. You hear me? Pause that video. Try these two. And then come back. You got to figure out which identity to use. You got to plug it in, come back, and then I'll show you if you are correct. Okay, so hopefully you worked that all out. And you're not cheating yourself here. So what do we have to do? 112? Well, how would you portray 112? Would you do it as 110 plus 2? Would you do it as 100 plus 2? Would you do it as 50 plus 62? Any of those are okay. I showed two different ways to do this problem. Here are the two different ways. Let's start with 100. This is the way I think most people do it. Maybe 100 plus 12. That's 112, right? So what do we got for 112? We get 100 squared plus 2 times 100 times 12 plus 12 squared. And then you're again showing each step here. You get yourself 12,544. But maybe you saw this as 110 plus 2. So if you did it that way, 110 plus 2, you get the same answer. How about that? That is what an identity is. It should get you the same answer either way. Now, we will take it either way. You just have to make sure that you show each step there. And there are other ways too as well. So let's look at part B right now. Here is the identity that I used for part B. I saw 27 as 30 minus 3. Now, the first step of this is to just plug the numbers in, 30 and 3. That'll give us 27, right? So wherever there's an A, you plug a 30, and wherever there's a B, you plug a 3, and then we simplify. So simplifying, 30 squared is 900. We get minus 180 plus 9. That's going to give us, what, 27 times 729. Now we got to multiply those out. Again, we'll give you a calculator. I get 19,683. Now, if you go to your calculator, and I'm doing it right now off screen, and you can check it by just plugging in 27 cubed. You know if you're right, right? Just plug that in your calculator, and you get the same answer, so you know you're right. Boom, super easy. Those are called identities. And now it is our turn to prove these polynomial identities. We're going to prove them. We're going to turn to page 340. That's where we're going, page 340. And we're going to verify each algebraic statement by transforming one side to show its equivalent to the other side. So I'm going to translate that for you. We're going to do a bunch of math on one side and get the exact same thing that's on the left. That's what they want you to do. So don't touch the left. It's going to stay v to the 6 minus w to the 6. I'll do number 1, and then you can practice with number 2. So here we go. All right, so I look at this. There's no like way that is better. There's a couple ways to do it. None of them are necessarily any better than the others as long as you don't break any rules. I'm going to multiply the first two expressions because we have no reason not to just, start doing that. These two expressions here, v squared minus w squared, and then v squared minus vw plus w squared, I'm going to multiply those out together. It's going to take distribution. I'll change the color here. Let's start multiplying. We get v squared times v squared. That is v to the 4th. And then v squared times a negative v dubs. So that's going to give us a negative v to the 3rd dubs. And then v squared times w squared. So this is something, honestly, it's not that hard to do, but it's hard to keep track of everything, if that makes sense. Because I've only done the very first term, and now I have to do that negative w squared. I'll use a different color for that. Let's go green. So we have a negative w squared times a v squared. That should give me a negative, and I love to stay alphabetical so I can notice all my terms. So this would be v squared w squared. Notice how I did that? It's w squared times v squared, but I'm just going to stay alphabetical here. Then I need to multiply the negative w times the negative vw. So again, I'm going to stay alphabetical, but a negative times a negative is positive. And then I'll have a v, a single v, and then I'll have 3 w's. And then lastly, I have that w squared times that w squared. That's going to be w to the 4th. It's a negative times a positive. That's negative. So this is the hot mess that I get from multiplying the first two expressions. I'm going to put it all in parentheses. I can't forget about that other expression, so I won't forget about that. I'll put that in parentheses over here. That's going to be v squared plus vw plus w squared. This problem sponsored by Volkswagen. All right, so now I'm going to look at this and say, is there anything I can simplify? Actually, when I look at this big ugly mess, notice how these two are the same but opposite? So we have a positive and a negative. They're going to cancel. So that was fun. And then we have a VW cubed and a V cubed W. Those are different. The rest of it's different. So I'm just going to rewrite that as simplified. So this is what we get when we simplify it because those middle pieces kind of fall away. But now it's the next part. I mean, let's look at it. We have a 4-termed expression times 3-termed expression. How many terms I give you? That gives you 12 terms. 4 times 3. That's tough. So I'm going to start with that v to the 4th. And I'm going to multiply this out, but you're going to see kind of some magic happen here. So that v to the fourth, I'm going to multiply by v squared. That gives me, I'm going to start over here because I know this is going to be a lot of stuff. V to the fourth times v squared is v to the sixth. And then v to the fourth times v dubs. That's going to give me what? V fifth and a dubs. Okay, and then lastly, I'm going to do that v to the fourth times that w squared. That's going to give me a v to the fourth w squared. And I'm done with that first turn. Thank goodness. I'm going to change colors. Now I have to do the second term. So we have a negative v cubed w times v squared. So that's going to give me a negative term. There are 5 v's and there's 1 w. Right? And then I have to do the same thing with the middle term. So I get a negative term again. And then I have 3 v's and 1 v is 4 v's. And a w and a w is a w squared. Ooh, that's a w. Got to be careful here. This could be dangerous. And then lastly, I got to do that negative v cubed w times that w squared. That's going to give me a negative term again. It's going to be v cubed and then w cubed. So I am now done with the first term and the second term. I'm only halfway done, though, because I have 2 more terms to go. So I'll change that color again. Let's go red. K-Town red. All right, so now we're going to do vw cubed times, I'll use the bottom now, times v squared. I get v cubed w cubed, because v times v is v cubed, and then w cubed times v squared. All right, so we get 3 v's and 3 w's. You know what I'm going to do? I'm going to do the rest of the term right now. I'll save you some of that time there to shorten the video, but when you multiply that times all 3, these are the expressions you get in the red. And then lastly, we have, what should I do? I'm going to go back blue. We have this last term right here. Negative w to the fourth times v squared is negative v squared w to the fourth. And as I said, I try to keep it alphabetical so I can see what's matching up. Negative v squared w to the fourth, and then a negative v w to the fifth, and then just a negative, these last 2 terms, is negative w to the sixth. Whoa. There's so many terms. I'm sure I misspoke in there somewhere. But now it's time to simplify. And here is the magic part. A lot of these are going to cancel. So let's try to find some partners. Here we have a v to the fifth w. Here we have a negative. Nope, I got to find another v to the fifth right here. Negative v to the fifth w. Those 2 can go together, but they're opposites. So I'm going to cancel them. And here's a v to the fourth w squared. Here's a negative v to the fourth w squared. Guess what? Cancel. Guess what? This show is on all week long. You can get it on Netflix. Are you still watching? Yes, I am. Look at this. V squared w to the fourth, negative v squared w to the fourth. They cancel. So much canceling going on. They cancel. And what are we left with? The very first term, which is v to the sixth. This is all going to equal v to the sixth, and then cancel, 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 minus w to the sixth. What? That's exactly what we started with. That was a lot of work, and you have to be very careful with your signs. But you know what you're supposed to get, so you know if you're right and you know if you're wrong. So now it's your turn. Which one are we going to have you do? Let's do number 2 right now. How about you do number 2 all by yourself, and then come back, and we'll see how it goes. So pause the video right now. I'm watching you, and do number 2. Okay, so this one here, I'm hoping that you tried it yourself. We are back, but I mean, here's basically what we have. I stopped halfway through because I want to show you some things. We're going to square this, so that means write it twice, right? And then multiply it out. So p to the fourth, p to the fourth is p to the eighth, and then we get a negative p to the fourth, q to the fourth, and then another. This is qp, but remember, I always write it alphabetical, so then I can recognize it, and they go together. On the right, a squared means times itself, so we're going to multiply it all out. So this is the part I stopped at, but if you notice, like these are like terms right here and right here. They're both p to the fourth, q to the fourth. So this is all going to equal p to the eighth, and then we have a negative 2 and a positive 4. That is a positive 2 p to the fourth, q to the fourth. Okay, and then we have that q to the eighth that's chilling at the end. All right, so you're like, now what? I'm almost all done. But look, this, let me show you something. You remember this thing over here? This identity? A plus B squared? Here's where I kind of like, I've memorized, I don't say memorized, I recognize. There's a difference. I mean, I have memorized it, but if you could recognize this, something squared, and then a 2ab in the middle. This is very close to that. This is close. If you let a equal, what do we need? P to the fourth. This all equals, when we work this all out, this is P to the fourth, right? Plus, and then the other term would be B, which would be Q to the fourth squared, right? That's what this whole thing equals, because it equals, that would equal a squared, which would be P to the fourth squared, plus 2 times P to the fourth, Q to the fourth, and then Q to the fourth squared. It'd be B squared. That's what that all equals. And if you notice, that's what we have over here. The trick to this one is being able to go from here to here, recognizing that this is one of those identities that we have. And those identities we will give to you. Maybe I'll give you a sheet with those identities on it. What do you think? Or I'll put them on the master check. I'll figure it out. But that is number 2 there. You have your classwork. We're all done here. That's the first lesson. I got to shut up because this video is getting too long. So this is Kelly. I'm at K-Town. Remember, it's nice to be important, but it's more important to be nice. See you.